Students, today we will see the very important topic in machine learning, that is the ensemble learning. The ensemble learning is basically more important when you are dealing with the supervised learning. And this supervised learning algorithm, we have many algorithms we have seen. So we have seen the regression. In the regression, we have discussed logistic, linear, polynomial, multiple. And when talking about the logistic is a part of the classification. So do not mix up the logistic regression with the regression. But that is the flavor of the regression, but that is undercome into the classification. And talking about the classification, we have seen the logistics, superconductor machine, and KNN. So there are many methods we have seen. But what is ensemble learning? Before moving to the ensemble learning, I will like to tell more detail about the ensemble one. So let's move to the next slide. That is fine. Ensemble method is what in the ensemble learning, and we can say the machine learning. So what is the meaning of the ensemble word? Ensemble is saying to us a group of the item viewed as a whole rather than individual. That is the meaning of the ensemble. Ensemble word is coming from the our very basic term, that is the assemble. What is assemble? Assemble means you are just to have the many parts of the information, and you're just trying to assemble all those parts to get the meaningful data. And but each and every part or each and every meaningful information we have, so that also having some own meaning. So if you're integrating all these things, you're combining or we can mixture of all the things, then what we are getting, you are getting a meaningful information. So ensemble method in machine learning basically is a technique that is used to combine the basic models, and by adding the basic models we can have the a model. So what we are doing, with help of the single model, we are using the our ensemble learning or ensemble method. But what we are doing in the ensemble learning, we are using a base model, and that base model could be the any regression approach, descent tree could be, and any classification model, but depends on the problem. And by mix of the all the these models, you are trying to make a model by which we can say that is the you have the one model. It is a simple example. I can take the very simple example. Suppose there is a 5 rooms: room number 1, room number 2, room number 3, and room number 4. If these rooms are also having the own identity, because each and every room also having the windows and door and some other points. So I'm taking general examples, then you can easily understand. So a room is also having the own identity. So we can say a room becomes a model, and this model could be any kind of the base model. So room 2, room 1, room 3, room 4. But if I'm integrating these 5 rooms in a combinations way, in a integration form, so room 1 to room 5 are the part of my common thing, that model I can say. So I'm integrating all these rooms or these models in a single model, and by getting the output in better way by such a model, then we can say this is our ensemble. Because what we have done, we have assembled all the rooms, all the models in a group. So what we are doing, as per the definition of the word meaning of the ensemble, we are writing or we are understanding a group of items viewed as a whole rather than the individually. So we will not say we are using the single model. That could be the descent tree, or that could be the regression, that could be the any classification model. We will use such model as a group of the items, or we can or it means in the ensemble learning model we will have many basic models. Step by step we will see. But what is the purpose of choosing that part? The purpose of choosing that part means if we are using if we are trying to solve such problem by a single model, there is no guarantee we can get the better accuracy or better result or better outcomes. So we are making the chain or sequence of the all the basic model, that could be descent tree or that could be classification model. Maybe we can get the better output because our information will be refined by the many channels. So that is the point we have over here, the ensemble method. Ensemble method is a machine learning technique that is combined several base models in order to produce one optimal predictive model. And to better understand this definition, let's take a step back into ultimate goal of the machine learning and model building. From this point, we have to start the whole thing. Okay, so that is the point where we can start our ensemble learning. And I'm remembering very simple example. In a room, there are the 60 or 50 chairs, but each and every chair has own identity. So each and every chair becomes a model. So in a room, we are integrating the many chairs. So we are integrating all the chairs in a room, or we are putting all the chair in a room. So room is also represented by the model, and we definitely, there's no guarantee, but at least we can say we can get the better result. So from this point, we have to start the ensemble method now. So let us understand this concept by the ensemble learning by taking simple example. Because I need to clear this picture in simple way. So I am taking a simple example you can easily understand. So what you are doing right now, suppose you are a movie director. So you are the first time you are directing a movie. So you have prepared a short movie that could be the 2-3 minutes movie. It could be depends upon your interested topic. So you need to take the feedback of your movie, what you have created, what you have designed, or what you have just prepared. So what you will do, you will take the feedback. What is the feedback, or what is the preliminary feedback or rating of your movie? So what you will do, you will distribute the copy of the movie to your friends, to your family members, to your relatives, to your colleagues, definitely. So this is a point from which we will to start. So let us understand this point. First, you may ask one of your friends to rate the movie for you. So there are the five friends. Suppose there are the five friends of you. So you are sharing your movie to the five friends. Some of are saying that this is a good movie, and some of the saying this is not a good movie. But they are your friends, so some of them are this is a good movie you have directed first time. It is nice movie, but what happened? There are some friends who never like to speak true. Okay, or maybe so they are saying, okay, this movie is not good, but they are saying this movie is good. But some of the are very truth friend, we can say, or true friends, we can say. And if you have not directed a good movie, so they can say you have not directed a good movie, so this is the worst movie. So what is your heart may broke, but you are getting the feedback. Because what you are getting the feedback, because out of the five friends, are two friends are saying it is good movie, and two are saying it is a bad movie or worst movie. One is saying okay, it is average movie. So that is the point you can see. So you are getting the input. You are getting the input in from the feedback from your friends. Next, you are now it's time to check your feedback from the colleagues. So you are distributing your movie to the five colleagues, because now they are not your friend. So there is some guarantee they can give you a better output. So what you will do, you will you will be sharing the movie to the your five colleagues. Then five colleagues are giving the input. So based on their inputs, you are thinking this movie could be better, or this movie could be not better. So you are getting the feedback, and you are trying to get the rating from the five colleagues. So that is from 1 to 5 rating. So 1 is the worst rating, we can say, or 5 is the best rating, you can say. So you are getting the some input from the your colleagues about your movie. So that is the one way. But you are still not satisfied. So what happened? You will distribute your movie to the other 50 or 250, whatever the count you want to take. So 50%. So some of them, so you're distributing the your movie to the 50%. So some of them could be your friend, some of them could be your colleague, or some of them could be your unknown person. So that could be a stranger. So that was the next point. So you are sharing your movie to the 50%, and I'm speaking once again. Some of them could be your friends, some of could be relatives, some could be your family members, some of could be your unknown person, stranger person. So try to get the feedback. So what is your movie? So this is the point. These are the three different questions. So from this point, we have to understand the point right now. So what I'm speaking over here. First, you have taken the domain on a limited. You are distributing a movie to the five friends, or some of giving the best movie. All are giving the best movie, but your movie input is not good. So there is no guarantee when you are doing something in the machine learning on the one by choosing the one algorithm. you may get the every time the better accuracy, or you may get the every time the average accuracy. So you have to change something. So that's why we have the various algorithm. I don't worry. I will tell you the practical part. If you're choosing a model, there's a classification model. If you're trying to solve by the SVM, if you try to solve by the logistic, if you try to solve by the Canon, so these all are the classification model. But which is the model by providing they can get the better output or better accuracy? So don't worry. I will tell you this point right now. But my point is over here, just you are distributing a movie to the 50%. So some of them could be the friend. So you are choosing the one domain. Some of could be the colleague. So you are choosing the another domain. And you are now rest of the could be the stranger person. So you need to check the feedback. So same if you are applying the ensemble learning here, what I'm having in the 50%, I'm having the very mixed kind of the people. So same thing, if I'm applying the mixed kind of the algorithm and I'm just defining this mixed kind of the algorithm, so combination of the various algorithms, if I'm choosing, then what is the accuracy, what is the what is the output I'm getting? So that is my point over here. So this is the ensemble. Ensemble means assemble the same group of the data item of different groups of the item as a group of the data item writers rather than the individual understanding. From this point, we have to understand the ensemble learning with the practical, but practically I will tell you later on, but let us understand all the things theoretically and what are its type. Now, tell me right now, the example is clear? This is a simple example I have taken. So from this point, we have to start the ensemble. Anyone who need to ask any question right now? This is the ensemble meaning. Yes, tell me right now.
Understood, sir.
Okay, good. This was a very simple example. So now, so the responses in this case would be the more generalized and diversified. So since now you have the people with the different sets of the skills. And as it turns out, it is better approach to get the honest rating because your friend are giving the false rating, then that would not be honest rating. So that's why I'm changing the mixed kind of the people. I'm choosing the mixed kind of the people to get the my rating. So that could be the honest rating. And the previous case we have seen. So with this example, you can see what we are getting. So this is basically showing the diversification in the machine learning is achieved by the technique called the ensemble learning. So because what we are doing the mix the all the things. That is the point from which we need to start the ensemble learning in the machine learning approach. And if you remember my words, have you remember the simple example when I show an image, in that image we have the regression. I'm talking about the supervised learning right now. I didn't talk about the unsupervised learning, and I'm also not talking about the unsupervised learning right now. I'm talking about the supervised learning. Supervised learning, you have remembered the random forest. Random forest is a part of the our supervised learning, if you remember. So that is the point we have to keep in mind. So random forest is a good example for the ensemble learning because what is the random forest I will tell you, but here step by step we have to ask. Now, so simple ensemble technique or what? We have three different techniques: maximum voting and averaging and weighted averaging. These are the basic or fundamental ensemble technique. So I'm using the rating example of the movie director example. So 1 to 5 are the movie rating is given to the my friends or my colleagues or the different people. So I'm taking the simple example. So what is the maximum voting? It's very simple technique. Just look at this technique in simple way. Maximum voting. So I'm not going to the just theoretical part unnecessary. I'm just taking a simple example by this point right now. Maximum voting means what is maximum voting? Maximum voting means out of the our number of the sample data, what is the maximum voting are giving to the such value, and that value will be our outcome. So colleague 1 is giving the 5 rating, colleague 2 is giving the 4 rating, colleague 3 is giving the 5, and colleague 4 is 4, and colleague 5 is respectively again giving the 4 rating. So 5 is coming 2 times, 4 is coming thrice. So what you are observing over here, our movie rating will be the final rating will be the 4. So this is coming from the maximum voting. So this is the maximum voting technique we have to use. Now it is clear right now. This is very simple technique. This is very simple technique. Just tell me right now. We have a three technique: max voting, averaging, weighted averaging, and averaging. Okay. These techniques will be really applicable in the our type of the ensemble learning when we will see. So where we can apply. So from this point, we have to understand the what are the basic and fundamental technique. So maximum voting. So now this is the our maximum voting. It is clear to all right now.
Yes, sir.
So what is the averaging? Same rating I am giving. Same rating I am giving. See, this is our rating. So colleague 1 is giving the 5 rating, colleague 2 is giving the 4 rating, colleague 3 is the 5, colleague 4 and 5 is giving the 4 rating. So with respectively that rating, if I'm doing the averaging, so what is the averaging? I can do 5 plus 4 plus 5 plus 4 plus 4. So divide by the 5, I'm getting the 22 divided by the 5. So what I'm getting? I'm getting the 4.4. So this 4.4 will be the your rating of the averaging you're getting. So this is what this is the averaging betting. So averaging I'm getting. So this is our ensemble technique we can see. So this is a simple example. This is the only learning purpose I'm taking here. No, numerical will not be asked like this one, but keep in mind this is the basic one. Averaging I'm getting. So how I can getting? So final rating of the movie I can give the 4.4. Now, weighted average. Weighted average is basically the extension of the our averaging method. So far we have seen. So all the methods are assigned different weights defining the importance of the each model for the prediction purpose. So in this case, what I'm getting, I'm giving the each and see, I'm getting the rating, and along with the rating, I'm also getting the weight, and weight is defined the importance of the each model for the prediction. So weight will be associated with our rating as well. So this can be achieved by the weighted average. So weighted average is a technique by which we can get the our rating. So what I will do, I will multiply the rating value to the respectively its weight. So from that point, if I'm doing so, I'm getting the 4.41. So look at this example. Now the example will be more clear. 0.23 is the weight of the colleague 1 who is giving the weight 0.23 to a rating 5. Colleague 2 is giving the 0.23 weight to the its rating that is his or her rating that is a 4. Same thing is happening with the 3, 4, 5 colleague as well. And so what I'm getting right now, I'm getting the 4.41. So the 4.41 is my final rating by choosing the weighted average method. So this is what this is the our ensemble learning method. So these three are the basic method, and that can be applied into the real life situation by following the ensemble learning. Now these are the three different methods. Now it is clear to all right now. Tell me it is clear to all. Or anyone who need to ask any question?
Clear, sir.
Okay. So this is we are talking about right now the this simple meaning. The simple meaning means we are talking about right now the what is the basic technique. So far what we have seen, so far we have seen the meaning of the ensemble word. Next we have seen the meaning of the ensemble learning, and next we have seen the what are the various methods by which the ensemble learning can be applied. But what is the our types of where we can use such kind of the technique? So this technique will be applicable into the various kind of the ensemble learning. And from this point, we need to understand where we are lying. So from this point, I have the type of the machine learning. So as we know, supervised, unsupervised, and semi-supervised. But here we are talking about the ensemble learning types. Ensemble learning types, we have three different types. Just let me know right now, the screen is visible about this point. Ensemble learning type is slide. It is visible to all?
Yes. Yes.
Okay, good. So from this point, you people are required to understand the thing properly. Ensemble learning type. So there are the three important methods. One is stacking method. When I'm saying ensemble learning, I'm choosing the stacking method. So here I'm talking about the maximum voting technique. So maximum voting technique will be applied. So the name of the algorithm will be voting ensemble. So when I'm saying I'm using the stacking method, I'm choosing the stacking method in the ensemble learning. So what kind of the algorithm, what kind of the approach I will use, that is known as the voting ensemble. And for solving the problem, what kind of technique I can use? I will use the maximum voting. So maximum voting is applicable over here. But this will be usable when I need to improve the prediction. So when I need to improve the prediction, then what I will do, I will use a stacking method, and here I have to use the voting ensemble approach, and max voting will be the technique, and that is implied in the voting ensemble. Next one, we have the sequential ensemble learning. Sequential ensemble learning is a very simple concept, and I will give you the diagram the by which you can easily see. And sequential ensemble learning here, this is known as the boosting ensemble learning. So in the boosting ensemble learning, what we have the add a boost name of the algorithm, add a boost, stochastic gradient, and boosting. These two are the our name of the algorithm that is applied in the sequential ensemble learning. And sequential ensemble learning is also known as the boosting. And in this case, we have the two beautiful aim of the algorithm. One is the add a boost, and next one is the stochastic gradient boosting. And the purpose of this algorithm to reduce the voices. Next, we have the parallel ensemble learning. This parallel ensemble learning is also known as a bagging. Please keep in mind all the its others name as well. So parallel ensemble learning, we have the parallel ensemble learning, and its other name is bagging. And in this case, we have an example that is the random forest. So if you remember the my slide previously when I taught the supervised learning, regression, descent tree, random forest, we have a term. So random forest is an example of the parallel ensemble learning, and the approach we have to use here, that is a bagging. So other algorithms are over here, that is a bagged decision tree, extra trees, and the purpose of this algorithm to reduce the variance. Now, these are the basic terms we have to keep in mind. So what are the other methods? We have three different methods. One is stacking, voting ensemble. Okay, so this is name of the example, name of the algorithm that is applicable in the stacking. So here you have to use the maximum voting. So you have to identify which kind of the algorithm or which kind of the learning types or ensemble learning I have to use. So, but the purpose we need to clear. If I need to reduce the biases, then I have to go for the boosting approach, and that is sequential ensemble learning. And here the name of the algorithm, that is add a boost, I can use. And if I need to use the parallel sequential ensemble learning, it means I'm talking about the bagging. So random forest is the best example. So what I have to use? I have to use the decrease the variance over here. So we need to identify its usability, and based on the usability, we can use respectively our algorithm. So let us start all the things step by step. Then I think the more idea will be clear to all people. Now stacking. Let us move to the stacking part. But before that, can anyone tell me right now? Any doubt over here? The ensemble learning type. Yes, tell me. Any doubts over here? So please tell me right now.
No, sir.
Yeah. Okay. Now let us move to the first ensemble technique, that is stacking. As I told you, stacking is what actually? Stacking means it is used to improve our prediction. That is the first part. Now, in this case, we have to use the voting ensemble method, and max voting is the best technique by which we can do. So stacking is an ensemble learning technique, and that uses a prediction from the multiple models. So what are the multiple models? If I'm talking about the classification, so I can choose the descent tree classifier, K-N, and S. So you can see here I'm choosing the three different algorithms. That is the basic algorithm. So we have the three base model, that is the descent tree classifier, K-N, and S. And by combination of all these methods, I'm preparing a new model, our ensemble learning model followed by the stacking approach. So if I'm getting the prediction by a combination of these three algorithm or these three models, then my new model will give the better accuracy maybe or better outcome. So what I'm doing, I'm just choosing the training data and testing data. So why? Because training data and testing data are the two important points. Because my model will be built by the training data rather than the testing data. So I will use the training data rather than the testing data. So training data I'm dividing to the 10 parts, and we have the 1, 2, 5, 4, 5, 6, 7, 10. These 10 data will be used to build my model. So that is the training data we can say. Now test data we have own meaning now. So base model I'm taking the descent tree. First I'm taking the descent tree as a base model. Please keep in mind my words. In the stacking what I'm doing. I'm doing the descent tree. So descent tree 1 to 10 the training data I have. By choosing these training data, I have to identify which data I have to choose as a maximum voting, because my data will be used by the descent tree. So I'm using descent tree. So by choosing the descent tree, I have the split data, my training data into 10 parts, 1 to 10. So if I'm choosing the descent tree, so what you are observing, by choosing the descent tree 1 to 10, my descent tree can give the randomly can give the these are the maximum voting or stacking base I'm giving. So stacking means 1 to 10. I'm stacking means I'm separating of splitting the my data. And maximum voting classifier we will use over here. A voting classifier is the name of the method in the Python we have to use. So by applying the voting classifier and by allowing the descent tree as a base model, so my descent tree will use the 10 different parts rather than the applying the functionality of the descent tree. First, descent tree will execute properly and it will have the data into the 10 parts, and then out of 10 parts with help of the voting classifier, maximum voting, which is maximum value, which is having by the maximum voting, we can say, we will choose as our outcome. And this process will also happen with the kernel, and this process also have been done by the as well. So what are our three base model? We have the three base model: descent tree, support vector machine, and SVM. By the combination of the SVM and kernel support vector machine, if the maximum voting I'm getting the maximum voting by value, any value that is a better value I'm getting, so that value will be our outcomes by the our to build my model. So here I'm just showing the my next example, next diagram. This is the this one. Look at this image. So after applying the descent tree, now I'm applying the kernel algorithm. So after applying the kernel algorithm, now next I have to apply the assume, that is support vector machine. So these three different base model I have to apply on the training data to build my model. So three different builds model and three different models are built. So what happened practically, what will be happening? First, my model built by the tracing tree. Next, my model will be built by the kernel. Next, my model will be built by the SVM. So what happened every time? I have to use the three different approach. So if I'm using the three different approaches, then what happened? Every time I have to deal with the training data. So training data will incorporate descent tree once, and then descent tree training data will incorporate the kernel and then SVM. So my computation cost will be high. So that is the point you have to understand. My computation cost will be high. So rather than applying these three combination, we have to use ensemble learning approach. We have two options. Either separately we can apply, or by choosing the ensemble learning we can apply. So if you're choosing the ensemble learning, then these three base model will be implied inside a model only. But if you apply separately all these three models, then what happens? The computation will be increased automatically high, because in training data will be associated with traditional tree once. Then next time training data will be associated with the kernel, and then next time training data will be associated with SVM. So three times training data will be associated, three different models will be built. So what happened? Computation cost will be increased automatically. But what happened? By combination of these three models, if I'm combining these three models in a group or in a box, we can say, and then I'm applying the training data, so my computation will be done. We can say 1/3 rather than the applying the three different build. So my one model will be built. That is the point you have to understand. Rather than the building the three different models. So my one model built, and based on these three base model, and my outcomes may better. Outcomes may better. There is no guarantee, but depends on the data set. My outcomes may better or accuracy may better. So that is the reason we have a ensemble learning, and that is known as the basic point. And by applying the voting classifier, what we can get the our maximum voting techniques. We can apply the maximum voting techniques. So what is the maximum voting I'm having? So I can get the point. But this is most applicable to improve the prediction. That is the point. Now this part is clear right now. Is it clear to all right now?
Yes, sir.
Okay, I can take a simple example. So for a betterment, there are three rooms. Now you are only the one person. Okay, you have as a person you have become the training data. Okay, now in a room you are going to in a room, then what happened? You have to solve the question paper and then you have to come out. Now again you have to go to the another room. Now you have to solve the question and then you have to move out. Now third room you are going to the another room and now you are solving. So how many times you are solving the paper? Three different papers you are solving. Three different papers, three different subjects you are solving. So how many rooms are occupied? Three different rooms. Tell me yes or no.
Yes, sir.
So rather than occupying the three rooms, it is better idea to I can give you the three different papers on the same room in a single room. So you are the only training data because you can only deal with the same paper. So rather than occupying the three rooms, it is a better idea to I can occupy only the one room and I can give you I can give you the three different question paper in a one room in a one room. So it's a better idea to rather than occupy the three different rooms, you can occupy only the one room. So that is the point. So ensemble learning will save the memory. So if you are saving the memory, so definitely computation time will be reduced automatically. That is only meaning. So that is the meaning of the ensemble learning. Now this example it will show the better idea. Now this clear to all right now.
Yes, sir.
Yeah, that is the point. Now, so this is the just idea about the stacking. Before moving to the another approach, just let me know right now. Any doubt in the stacking part? Yes, tell me. Anyone who need to ask?
No doubt, sir.
Okay, great. So I'm not going to the unnecessary theory point. This theory point you can read out only the notes purpose only. So I'm just moving to the next point. That is the backing. Let me inform you once again over here. Few couple of the minutes we have seen the backing. Backing is an example of the parallel ensemble learning. The backing is an example of the parallel ensemble learning approach. And what is a bagging? And in the bagging, we have an example of the our algorithm. So I'm not talking about right now the algorithm name. I'm talking about the bagging approach. So bagging is what? Bagging word is combining from the two important words. One is a bootstrap and then is aggregating. So the idea behind the bagging is a combination of result of the multiple models, for example, dysentery. So in an to get the generalized result. So here is this question. So if you're creating all the models the same data type or the combined, will it be useful? That is a big question will be mentioned over here. And it is also mentioned over here. If you're solving a problem by the dysentery, then it's okay. But if you're solving the same problem by the dysentery, so you're just unnecessarily wasting the time. So why we have to use a bagging? So bootstrapping is the approach. Let me inform you. So bootstrap is the approach by which we can use the base model as a, suppose I'm using the base model as dysentery. In the next time, definitely I have to apply on the my same data set or same training data, but what I have to choose? I have to pass a different parameter. So this bootstrapping is basically a sampling technique that is saying to us, first you are building the model by the 50% training data, but you are using the 50% data, that is no issue. But you are changing some parameter. You can change the parameter, you can change the sampling size, you can change the any other method, you can change the other parameters. Suppose dysentery I am using, Previously, I'm using the calculating the I'm applying the entropy. Okay, in the dysentery, you can get the entropy. You can apply the Gini index method. You can apply the other method. So parameter you can change. So that is the point you can see observe over here. Bootstrap is a technique, and that is a sample technique. It is saying to us you are creating the subset of the main data set to give you the subset to the your different trees which are representing as a model. For let me inform you all by the example, that information will be clear to you. This picture is clear to right now. This picture is clear. This picture is visible.
Yes, sir.
Okay.
Yes, sir. Visible.
So okay, good. So here I am taking the simple example, so I can explain the tagging. That is the point you have to understand. Please listen. This is tagging a very simple example. We have a data set. I can write over here data set. This set is known as the population. Please keep in mind. This data set is known as a population. In mathematically, I can say. So this is our entire data set. This is also known as a population in mathematics. So if I'm choosing the base model as a descent tree, so I'm just making as a descent tree. So descent tree I'm applying. So first descent tree I'm getting applied over here. Next, I'm also using the descent tree on my sim data set. So if I'm applying the descent tree on my entire data set, then that's definitely no issue. So what is the bagging? What is a bootstrap? So bagging stands for the bootstrap aggregating. So let me inform you all what I'm doing right now. What is the meaning of the bagging? In the bagging, what I'm doing, I'm not using the 100% data set over here on all the dysentery. So dysentery is my base model. Suppose keep in mind. So I'm assigning suppose I'm assigning the 30% data set to the dysentery one. Now next time I'm assigning the 25% dysentery data set to dysentery this one. Next, suppose I'm assigning the dysentery 3 I'm taking. I'm assigning 25% data set to this one, and now next I'm choosing the dysentery 4, and this is suppose following by the 100%, so we can say 20% only. So what I'm choosing right now, I'm having the base model dysentery, and on which I'm assigning the data set. So 30%, 25, 25, 20. So what I'm doing, I'm assigning sampling. Sampling means subset of my data set. Sampling means I can write over here. Sample means subset. Sample means subset of the sample means subset of my data set. So this is sample. Okay, please keep in mind. So this is our bagging. This is bootstrap. So sampling is distributed. Sampling is assigning by by applying the bootstrap technique. Now listen. Here, read this point. Bootstrap is a sampling technique in which we create the subset of the observation from the original data set, and with the replacement, the size of the subset is the same as the size of the original set. Okay, so the entire size, suppose I'm just 30, 20, 40, or I'm adding all this in 100% data set I'm getting. Now this part is clear right now. Tell me, is it clear? Tell me right now. It is clear to all right now?
Yes. Yes, sir.
Okay, so what is I have done the bootstrap so far. Now I'm aggregate all these models in a group. Please keep in mind. So this is our model 1. Suppose this is our model 1. This is our model 2. And this is our model 3. And this is a model 4. So if I'm trying to aggregate, please keep in mind aggregate or I'm aggregating, and this is the sampling is just done by our bootstrap. This is done by the bootstrap. So if I'm adding these two words, so what I'm getting? If I'm adding these two words, so what I'm getting? I'm getting the bagging. I'm getting the bagging by applying the aggregating and by applying the bootstrap. So what is the definition of the bagging right now? Bagging or bootstrap aggregating technique uses these subsets. These subsets are also known as the bags to get a fair idea of the distribution and complete set, and the size of the subset created for the bagging may be less than the original set, and that is the bagging. Now clear, this bagging is clear, and this is the technique, this is our method, or this is kind of our ensemble learning. So this is also applicable. And rather than the decision tree, we can also introduce the different other methods. We can also have no issue. Now clear right now? This is clear right now?
Yes.
This exam, this is a bagging method. So I'm not going through the unnecessary theory, but I'm just explaining my idea with the help of a simple example. So with other slot, I have taken this example. So this is the point. This is the original data. So original data divided into the subset D1, D2, D3. Okay. So this is also known as a bag. So what I'm creating the bags. Okay. This is known as the generating the bags. So multiple subsets are created from the original data set, selecting the observation with displacement. A base model that is known as the big model as well is created for on each data on each of the subsets. The models run in parallel and independent of each other. That is a beautiful terms you have to keep in mind. So let me highlight these points. Please keep in mind. These models run in parallel. This runs parallel means what is mean by the parallel? And can anyone tell me right now what is mean by the parallel and independent? Can anyone tell me right now what is mean by the parallel and independent word over here?
Means they are trained at the same time, but they are independent of each other.
Yes, this is a point, but you can observe over here 30% of the data. You can see this image right now. We have created a few seconds ago. If I'm using the 30% of the data set, that is a subset I can say on the descent tree one. So this descent tree will execute it only following by the 30% data randomly chosen. 25% data I have chosen randomly for the descent tree 2. So descent tree 1, 2, 3, 4 are executed simultaneously or parallelly, following by the its respectively subset. That is the meaning of. So descent tree 1, 2, 3, 4 are independent from each other. That is only meaning. Now it is clear? That is
Yes.
meaning. That is the meaning. Yeah. So final prediction are determined by the combination of all the prediction from all the models. So from all the models, I'm getting the prediction. Model 1 is model 2, model 3, model 4 are giving the prediction P1, P2, C. So I'm getting the prediction. So from this prediction, I need to identify which model is giving the better prediction. So from that point, we can get. So that is the only point. Now, original data I'm getting, so descent subset 1 descent subset D1, D2, D3, D4, D5 are generating following by the its respectively models 1 to 5. And now P1, P2, P3, P4, P5 are the various prediction from the our models which are generated some prediction. And we are combining all the prediction, and we can get, or we can determine the better prediction, and that is now known as the ensemble learning. So that is our ensemble learning example following by the backing. This is another image T1, T2, T2. So what is a random forest? Here I student ask me questions of what is random forest, because random forest is an example of the our algorithm name of the bagging. So bagging and we can say parallel ensemble learning. We have to parallelly execute all the base models parallelly, and all are independent from each other, and this is approach which is known as a bagging, and the algorithm we have the random forest. So random forest is basically a machine learning algorithm, and that is saying to us which base model you have to use. You have to use the base model as a descent tree. Why? Because a tree and the data structure or in the mathematics we have this term right now. What is a forest? Forest is a collection of the trees. Tree has own identity, but what is a collection of the tree? We can say that is a forest. A forest is a collection of the descent tree. So in the descent tree we have the many descent tree. So in a random forest we have the many trees. So random forest means randomly our trees are occupied or trees are used. So we can have the n number of the trees in a random forest, but we have to choose the or we have to use the trees by the random forest. So random forest term is coming from the machine learning. That is we have to use base model as a descent tree, and random forest is the best example of the ensemble learning where we can use the base model as a descent tree only. So that is only point we have to understand. So random forest is a collection of descent tree, and it is also known as the classifier. This is random forest itself is a classifier, and we have to use a term that is a random forest classifier RFC as a practically. We have this model as well. So this is the point. So in if anyone asks to this question at the time of the interview or when anyone asks the question, what is mean by the random forest classifier, then you can easily say random forest classifier is an ensemble learning, is an example of the ensemble learning inside the machine learning approach. And random forest classifier used to classify, it is used to classify the data and which is provide the better result. Why? Because it is use a base model as a descent tree, and descent tree classifier is the best for the classifier regression as well. So if you remember the same example, descent tree classifier is the best as we have seen, but logic regression is better. No one can do. So descent tree classifier we will use as a basic classifier inside the random forest. So random forest is saying to us it is a collection of the many descent trees. You can't say a random forest is a collection of the suboptimal machine or canine. But as a we have to justify that this logically we have to use a term. So descent tree. So while implementing the random forest classifier, you have to use the descent tree classifier as a base model. That is the point you have to understand. Now clear? So random forest we will implement, but this point should be clear right now. And that is example of the value. Now it is clear to all right now?
Yes, sir.
Okay, so these are only the points we have to keep in mind. Next, we have a very important terms, boosting. Boosting is a sequential process. Now, why? As we have seen in the types of the our ensemble learning, what we have been observed, sequential ensemble learning is known as the boosting, and in the boosting we have used the add boost. So add boost is the name of the algorithm that is used to perform the boosting approach, but it is sequential process. So how we can say it is a sequential process? Can anyone tell me right now how we can say it is a sequential process? Anyone who have just any idea? So please you can tell me right now. Boosting is a sequential process. Can anyone tell me right now how it could be? If you remember anything, just please you can share an idea. Tell me, share your idea right now.
So it is similar to neural network. So means we are in neural network also we have means a chain when we do the loss function after that when we correct the weights and bias then it's also chain reaction, and in this also so the model means the upcoming model is all means it try to correct the error of the previous model, means the upcoming model is upgraded version of the previous model which try to correct the errors of the previous model, sir. So they are
Yeah.
dependent on each other.
Yeah, okay, got it. So what is we have the simple meaning? We have a sequential process. Suppose in the model 1, model 2, model 4, model 5 we have. So model 1 is sharing the data to the model 2 then if we are not preparing or we are not generating the model 1 as a success manner, then what we have to find the error, we have to troubleshoot such error. After troubleshooting the error, we can move to the next model. So before moving to the next model, it means model one output is depend on the model or two, or we can say model two is depend on the model one. So we have a sequential process, and that is the point over here. So let us understand this thing by an example, because it is not independent. That is a little bit difference you have to identify. Look at this diagram. In the backend, model 1, model 2, model 4 we have. So that is parallel process. Random forest is the name of the example we have seen. Boosting. Boosting what we have? We are moving from sequential left to right or right to left, it doesn't mean. So model 1 is okay. So then we have to move to the model 2. Then model 2 is okay, then we can move to the model 3. But we are finding over that error, model 2 is just having the error. So what we have to do? We can't move a model 3, or we can't execute model 3 process before completion of its execution of the model 2, that is a model 2. So model 2 is just having the error, so what we have to troubleshoot. And the name of the our sequential ensemble learning, we have the name of the algorithm, that is adapt boost. Name of the adapt boost is just, we can say, coming from the two words, that is the adaptive boosting. Adaptive boosting, it means boosting or sequential ensemble learning we can adapt dynamically. So whatever changes we are doing in the model 2, so it should be run perfectly and without any error, then we can move to the next model. So next model is model 3, and same process we have to identify from the model 4. So model 4 will execute before completion of its the model 3 should execute properly. So model 3 should not have any error. So then you can move. So dependency we have to over here. So we can say in the boosting, models are dependent on each other, and it is not a parallel. It is a sequential process. And the name of the algorithm, we have the adapt boost. Now this is a simple example I have taken over here. Now it is clear. Yes, tell me right now it is clear.
Yes.
So this is a simple example I'm taking also. Adapt boost means adaptive boosting. So model 1 is just does not have any error, so error 0, so no error. So model 2 also having error, suppose 0.01, so we try to correct the error. Then model 3, so model 3 can be boosted up when mod M2 does not contain any error, and then M4, N4, and so on. Okay, this is the simple critical portion I am giving over here, so I'm not moving to the unnecessary theory. You can read out the theory from the my notes. I would like to share this image. It is visible to all right now. It is visible to all. This image is visible.
Yes, sir.
So you can see, yeah, good. So in the bagging, so I'm highlighting in the bagging, enter data set we have. It is divided into the subset 1, subset 2, and subset n. So what we have? We have the distribution. Just look at this, my yellow color highlighter. I'm just highlighting. So we're dividing. So dysentery 1, dysentery 2, dysentery n, that is a fit or that is built by the subset 1, 2, 3, and respectively n. So these are the independent from each other. But when talking about the boosting approach, then boosting is saying to us, this data set we are using, entire data set will be use the dysentery, and then we have to pass this information dysentery 1 to dysentery 2, but dysentery will be prepared or will be generated as a model, because a success model. Then if there is any error, so learning from the mistakes, if there is any error, so we have to troubleshoot such error, or we have to adjust our data set towards the our output, and then we have to pass the information to the next model, that is the dysentery 2. So this process will go on, this process will go on to the n number of the tree. So look at these three different points, and now you can see, observe over here, dysentery 1, 2, n, and dysentery 1, 2, and also having the name as a dysentery, same model I'm taking as a base model, but these trees are look like not the same way. It means because they are generated, dysenteries are using the different data set, and that is known as the subset. By using the different subsets, so that's why we have this term. So this is the better picture which depict the proper classification or proper differentiation between the bagging and boosting. And I'm speaking once again, bagging is the best example. We have in the bagging random forest, while in the boosting we have the best example as a our add boost algorithm. Now the picture is clear right now. This idea is clear to all right now.
Yes, sir.
Yeah, differentiation should be clear. Okay, thank you. So what are the algorithms we have to use on the bagging and boosting? So in the bagging, we have the bagging meta stream method, algorithm name, random forest as I spoken many times. In the boosting, we have ADA boost, GVM, XGVM, light GVM, and cat boost. So if you heard all these terms, so you have to keep in mind what is the type of the ensemble learning we will follow. So when you try to search over the internet from the ensemble learning, so you have seen many algorithms. So you try to identify which is the algorithm and which is the kind of the algorithm we are following. What is the type of the algorithm we are having. So in the boosting, we will use the adder boost and we will use the random forest. That is only for the practical part. Now, clear right now? Yes, tell me right now. Anyone who have any doubt? Just tell me right now. It is clear, or anyone who need to ask any question?
Clear, sir.
Okay, and okay, good, thank you. So, a student asked me questions. Sir, you talked about the maximum. Just talked about the boosting and packing. But do you have any idea the picture to pictorial representation of the maximum booting? Yes. So enter data set. I'm dividing the subset and subset one to up to n. So step number 3 is saying to us from the testing data set we have to predict the model predict prediction, but prediction 1, 2, 3 up to n. So out of these prediction, what I'm applying the voting approach, and this voting is approach done by the voting classifier. So what I'm doing right now, I'm applying the stacking because subset by choosing the subset one, this part that is a dysentery one will be built and dysentery one will predict the model by choosing the testing data. So it has own part, own stacking. So from this stacking one, stacking two, or we can say the dysentery one, dysentery two, dysentery, and we have to predict our model. So suppose I'm getting, I can write over here. Suppose I'm getting the prediction 1 over here. I'm getting the prediction 2 over here. And then I'm getting the prediction n. So in the maximum voting, by choosing the maximum voting, what I'm getting from the prediction 1, from the prediction 2, and so on from the prediction n, I have to apply the maximum voting algorithm over here, and then I can get the better prediction over here. So this better prediction, I'm coming from this one right now. So final prediction is coming from the majority of the voting. Please keep in mind majority voting for each candidate in the test set. So from the n number of the test or n number of the prediction, I need to find which is the majority I'm getting. What is the majority I'm getting? So from this point we have. So this image can be also understand this way right way. So this is following by the our stacking, or we can say maximum voting. This could be the example of our maximum voting, or this is also maximum voting technique it is used, but this is also known as the voting ensemble actually. So in the exam time, I can ask this kind of the question into different ways. So you people must be ready. Just try to understand the question. So this is also known as the voting ensemble. I can write over here. Way better way. Now this is clear to all right now. This is clear. This image is clear.
Yes, sir.
Okay, great.